let's proceed to the next topic, which is refraction of light. Have you observed, look at this photo, okay? So you see here a swimming pool. Have you observed that when you look at the bottom of the swimming pool, you can see shadowy ripples. The water is unstable, it keeps on moving, for example, and this causes the rays from the sun, for example, or any source of light to change its direction. So there's actually the bending of light rays when they travel from one material to another. And that is what we call refraction. Actually, we can see refraction everywhere, okay? From the sparkling diamonds. Yes, you heard it right. Refraction makes it possible. So you appreciate the beauty of these diamonds. And we have the twinkling stars, okay? And of course, okay, so the pencil is partly immersed in water. So because of the refraction of the light coming from the part of the pencil that is underwater, the pencil appears broken. So the word refraction is related to the word fractured, meaning broken. So refraction occurs when a ray of light travels from one material into another. The ray of light may change direction, okay? We can investigate this using a ray box, okay? So let us have our second experiment to show to you how refraction of light happens with the use of the perspex or rectangular block. And we also need the laser, okay? We also need the protractor, the ruler, pencil, and paper, okay? Okay, this time let us investigate refraction. So the skills here we will demonstrate knowledge of how to safely use techniques, apparatus, and materials, including following a sequence of instructions where appropriate. So we make and record observations, measurements, and estimates, interpret and evaluate experimental observations and data. So we will still use this laser to investigate the refraction of light by a glass or plastic block. Okay, so first we will place this rectangular glass or plastic block. Okay, we can use different things, or we can say perspex, all right, in the middle of a sheet of white paper. All right, so now let us draw around the block to record its position. Okay, there you go. Okay. Now, using a ray box, direct a ray of light at the midpoint of one of the long sides of the block. In this case, here or here, but we will, of course, use this one. All right? So now, observe the refracted ray passing through the block. Okay. Look at that. All right. So let us mark 2 dots on the incident ray to record its position. To record the refracted ray, mark where the light enters and leaves the block. So point X and Y. So we will remove the ray box and the block right after. Okay, so look at this. All right, as we direct a light here, okay, let's mark this position. Okay, so there you go. As you can see, there is an amount of light being reflected right here. Okay, so, and of course, it exits right here. Okay. All right, and of course, the origin or the light source. Okay, there you go. All right. So, as we mark 2 dots on the incident ray to record its position, all right, now we will use these dots as a guide. So let us remove this block and the laser. So we will now lay the ruler along the position of the incident ray and draw a line to represent this ray. Okay, so here, this one is the incident ray. Okay, now we can draw a line to represent this ray. We will repeat the same procedure for the refracted ray. Okay, so, all right, as you can see, now the bending of this light ray is pretty obvious. There you go. Okay, all right. So now, let us mark the angle of incidence and the angle of refraction. We measure these angles and record their values, okay? So how do we measure or how do we mark the angle of incidence? Okay, so first of all, don't forget to always draw the normal line, okay? Which is perpendicular to the surface of the mirror, okay? And to the position where the light ray hit, okay? So, again, it's safer to use the protractor. And there you go. Okay, so it must be here. Then we can now draw these dashed lines. All right. Okay, so this time we can now mark the angle of incidence, and the angle of incidence is right here. Angle of incidence. And we have the angle of refraction right here. Okay, now let us measure. So again, let us do this. Okay, this way. All right. Okay, so as you can see, it's around 1, 2, 3, 4, 34 degrees. But what about the angle of refraction? Okay, let us do it this way. Okay, so it's around 21, 22, 23 degrees. What have you noticed? Okay. You will notice that the direction in which the ray bends depends on whether it is entering or leaving the glass. So again, the word refraction is related to the word fractured, meaning broken. So refraction occurs when a ray of light travels from one material into another. The ray of light may change direction. You can investigate this using a ray box and a block of glass or perspex. Okay, so now note that the ray travels in a straight line when it is in the air, okay, outside the block. And when it is inside the block, it only bends at the point where it enters or leaves the block, as you can see right here, okay? So it is the change of material that causes the bending. In this case, the air and the perspex, or the air and the glass block. So from this experiment, you will notice that the direction in which the ray bends depends on whether it is entering or leaving the glass. So the ray bends towards the normal, as you can see here, when entering the glass. So this is our normal line right here, okay? So here, no bending happens, but as it enters the glass, the ray now is bending towards the normal, okay? So the ray bends away from the normal when leaving the glass, okay? So one consequence of this is that when a ray passes through a parallel-sided block of glass or perspex, it returns to its original direction of travel, although it is shifted to one side. When we look at the world through a windows, for example, through a window, we are looking through a parallel-sided sheet of glass. We do not see a distorted image because although the rays of light are shifted slightly as they pass through the glass, they all reach us traveling in their original direction, okay?